or if you're absent for the day. Hey, what's up?
Number 15 is easy, but I did it just now.
Okay, number 15? Okay, let's check it both times. So number 15 gives us... Oh, you got it? Well, guys, it's going to be a bit of a party today. Well, my computer's being all kinds of funny. Okay, so number 15, Kayla figured out that she just wrote down the problem wrong. It totally happens. But does anybody have any other problems that they got wrong? Yeah, Angie, gosh.
17 and 18.
17 and 18. Jerry, which one? 19. Let's take a picture of both. Well, let's start with 17, 18, then we'll go down to 19. And you guys are used to in homework, it kind of getting harder usually as you go farther down, right? So it's not crazy that these ones got a little trickier. Remind me from yesterday and help Andrew out because he was gone. Max is still gone. But let's just try to talk through it verbally real fast. What's the objective? What's the goal? What are we trying to get by itself? Well, we are eventually trying to get the R or the S, like the X alone. That's true. But what are we trying to get alone even before that? Yeah, the square root of the radical. So I had people yesterday, Andrew, this is, I think, really helpful for a lot of people. I had people go find the radical and put a box around it and then think to themselves, how do I get it alone? How do I get it alone? And so for this one, for number 17, yeah, did you guys add 7? You would have gotten that radical alone, 5r plus 1 equals, now careful with negatives and positives, just a few of you, this is like your Achilles heel, this is your, it makes me get problems wrong all the time. Negative 1 plus 7, they have opposite signs, so they're going to clash, and when they clash, they take away from each other. I say take away because you always think subtraction. It's a 6, why am I making it a positive 6? Who won the battle? Positive 6. Now, why are we getting that square root by itself? How do I get rid of the radical? I have to square it, right? I have to square it. So if I square both sides, how to undo a radical is by squaring. When I square both sides, then I can say, hey, squaring a square root undoes that square root. I have 5r plus 1 is equal to, what, 6 times 6? 36. You guys were being careful in squaring last night, right? Okay, 6 times 6 is 36, and then good old-fashioned algebra. Walk me through. Yeah, subtract the 1. 35 is equal to 5r. So therefore, r is equal to? Did you guys divide by 5 to get 7? See it? So the last step that I didn't show yet, I kind of start to do mental math after a little while. 35 divided by 5 is 7. So then 18 is super similar. Right? Oh, my box went, was that a minus or a plus? Okay, thanks. So that should have been a plus 4, right? Okay, good. Thanks for double checking. I couldn't see it. We got that radical, oops, it's an S, by itself for the whole purpose of getting the square root so we can square it. And so when we bring that square in, now all of a sudden that radical is going to be gone. I've finally gotten that expression free. That expression, 6 times 6. Oh, that was 36 also? Huh. That's weird. Plus 4. Andrew, how's it looking?
I forgot to
So you were trying to square too early. So remember, gotta get that radical alone first. And if it helps your brain, draw that box, because that's telling your brain, okay, wait, I need the box alone. Now square. And then Jerry, you said number 19, yeah? Was it kind of similar as far as, oh, it was written in a little bit different order though, huh? So number 19, we can still do the same trick of getting that radical alone. But guys, to get that radical alone, how do I get rid of that 7? Yeah, struggle, right? Think PEMDAS. To be honest, I think I would actually even draw the box here. I'm telling you guys the radical. The radical is right there, but check it. It's 7 plus 3 times. PEMDAS. PEMDAS says add after you multiply. What that means is this is stuck together, and I have to get rid of the 7 first and then get rid of the 3. So some people might have, and Jerry, I totally understand why you did it. You're like, yay, I want to make that 4. The problem is we technically need to subtract the 7, but that 3 gets undone with division. Does that kind of make sense? Yeah. So your brain just wanted them to go together, but without parentheses saying start there, it was illegal. But now I can totally go ahead and be like, hey, a few of you yesterday would have tried to subtract the 3. Remember, it's 3 times. How do you undo multiplication? Divide. First do it on one side, do it to the other side. And then I have finally gotten my square root of 11. When I finally get my square root of 11, now it's time to bring in the square tool. The same way I bring in subtraction to undo addition. The same way I bring in division to undo multiplication. I bring in the inverse of this guy, squaring, to undo the square root. And then I get, oh my goodness, everybody was 36. This is ridiculous. Oh well. Oh well. 6 times 6 is 36. I guess they wanted you to not forget the square. For whatever reason. So Jerry, I think probably at this point you're good. Yeah. Add the 9. 3p is equal to, is that 45? Mental math is? And p is equal to, in my head, just in case you're wondering if your brain doesn't know how to tackle this, I just think of long division, which is how I'm going to get my final answer. Alright, good question, because all 3 of those required multiple steps, especially that last one that needed a subtraction and a division before the squaring, and then it still needed addition and division too. So there's a lot going on. Anything else that you guys want us to see from homework last night? Awesome. You know what that means? That means that we had, hopefully, we did a good job on homework. We had success in doing our homework. So can you guys just go ahead and hold that up for me? Let's just get it graded right now. If you're like, I have it, I finished it, I rocked it, sweet, let's get you points. Let's get you points right now. Andrew, you were absent, so no stress if you don't have it, bud. But for everybody else. Rocky, do you have one? Oh, I have one. You need to reach out and show me. Oh, yes. Good. I can't see everyone when I'm doing examples, so I just want to make sure we weren't being distracted. Yeah, I wouldn't try it if you could do it. Can you see it? Ready to go now and not miss more class. Okay, so Andrew was absent. Everest is going to show me later. Brooke, it's in your homework file. Alyssa, Hannah's gone today. Max is gone today. Wow, I think she's there. You guys gone today. Skylar's gone today. Did I miss anyone else that's gone? Hey guys, go ahead and flip over to the other side of your worksheet because we started it yesterday, but we definitely didn't finish it. We started it, but we definitely didn't finish it. There's this vocab word we need to figure out today called extraneous. There's this vocab word that we need to figure out today called extraneous. I want you guys to start in the warm-up. Let's start easy. I mean, after last night, this shouldn't be a problem at all. Start in the warm-up on 10.3b. Start on the warm-up on 10.3b. Warm up. 10.3b. Warm up. Warm up. 10.3b. Warm up. Doesn't look near as hard as the ones last night, right? All right. 10.3b. Warm up. The warm up. Now, I'm going to do something kind of crazy that I didn't make you do at all yesterday. Maybe I should have. But after you solve this guy, which really should not take much time. After you solve this guy, which really should not take much time, I want you guys to check. I know, it's one of those annoying directions that math books since forever have been like solve and check. Solve and make sure. Solve and double check it's the right answer. It's kind of annoying, it's kind of tedious. But wait a minute, this one is so much easier than yesterday. And didn't take much time at all. And there's a reason. This one is so much easier than yesterday. I'm totally allowed to ask you to not only solve it, but also check it. Hannah, we're in 10.3b for worksheet.
Thank you.
And there's a very important reason as to why I'm saying check. Now hold on, how do you ever check an answer in math? You go backwards. So you take it and you plug it in. So Everest and Andrew, I don't just want you to solve it, I want you to check it. I want you to have what you think the answer is, and I want you to check by plugging in. So do it. Because right now, everybody should be having a little bit of an identity crisis. Did you try to check? Did you try to plug in? Was it good or was it bad? Was it good or was it bad? It should have been bad. Wait, what? No, this is easy. Look, it was so much faster than like all of homework last night. Because all you had to do was square both sides. And so I went around the room real fast as I was like walking around. And I saw a lot of you put 4. You're like, oh, easy. 100% ready for the quiz. Except I asked you to do what without answering? Check. And so to check, you're supposed to take this original expression and say, okay, if you're really the answer, this is supposed to work. But what happens when we plug in a 4, guys? It's a positive 2. Does a positive 2 equal a negative 2? So, you guys are being introduced for the first time to something that happens in math with much more complicated functions or operations than addition, subtraction, multiplication, and division. Do you guys remember? And maybe, if not, say no, it's okay. But do you remember, try to think back, that the domain, that's like the how left to how right thing, that the domain of square roots is only some x's, like x greater than something, or x less than or equal to something. The domain is only for some x's, meaning this guy, this square root guy, only works sometimes. When do square roots not work? When the underneath is a negative, right? Armando, let's put that phone away. Let's focus entirely. No, away, like underneath your desk. Thank you. And then Joseph, Andrew, and Armando, let's pay attention. You cannot have negatives underneath a square root, or it doesn't work. And you guys have all tried this in your calculator. At least I tried to have you all try it. And your calculator should say something like error, doesn't work, no solution, undefined. Your calculator says no. I don't know what your phone says. Did they try to do a negative number in their phone? Can you do a negative in your phone?
Yeah.
I don't think it works there either. So whenever you try to do a negative, it doesn't work. What that means is that the square root only works sometimes. Now, we saw yesterday that whenever you put a square in, it helps you ignore or take away the radical. The squared helps you ignore or take away the radical, but here's the hard part. If you are ignoring or taking away the radical, you're going back and saying, you know what, any number is okay. Any number is okay, I don't care. Andrew, stop talking. So if I square the square root, any number is okay, but in the beginning, not every number was okay. So here's this dilemma. Whenever we do this thing in math called inverse operation, which up to this point has been super basic as far as like adding a negative, or subtracting a positive, or dividing a multiplier, or multiplying a divisor. Whenever we do the opposite of something, it hasn't made an issue, because, okay, whatever numbers work to begin with will work at the end. But as soon as we start ignoring things like square roots, or someday ignoring things like natural logarithms, or ignoring things like trig, whenever we start ignoring what's there, very legally, you're allowed to put a squared and ignore or undo. You're going to have these little guys called extraneous solutions sometimes happen. I want you guys to look. Ooh, wait a minute. 3 and 4. I think we did those yesterday without even really meaning to. We're going to get back to 3 and 4. I think we did it in the graph instead of doing it on the paper or under 3 and 4. We'll get back there. This is what I'm trying to get to, though. Extraneous. You're a note-taking person. It's a good place to take notes. And if you're not a note-taking person, there is a place to do this in your worksheet. You should box the word extraneous, and you should tell yourself something about it. There's a new vocab word that's going to show up in this end of homework. All right, lessons, here we go. Extraneous is a vocab word. And it's something that, to be honest, you haven't seen hard enough math yet, to really ever see this before. Because I don't think you have. But as soon as we started having things that only sometimes work, like square roots, we have this possibility of extraneous solutions coming out. Because here's the dealio, guys. We can get rid of the square root and be like, no big deal, yeah, it's 4. But when you go to plug back in, you're like, wait, no, it's not 4. That doesn't work. And the reason it doesn't work is because at the very beginning, based on the definition of square roots that only sometimes work, can a square root ever equal a negative number? Is the question that we should have asked before we ever even started. Can a square root ever equal a negative number? And the answer is no. Because this square root guy, if you guys remember, he's the one that 0, 1, 4, 9. We plug in, and we get 0, 1, 2, 3. And when you graph him, you get 0, 0, 1, 1, 4, 2. And we can keep on going, 9, 3. Does this guy dip below the axis and ever go negative? No. It's impossible. Not that you can never have negative numbers if this guy gets shifted or if he gets flipped. But a good old-fashioned square root of x says, by definition, I'm the positive answer to whatever you put underneath me in the square root that is legal for me to solve. So the crazy thing is that this was an impossible problem, and that's why Isaiah said a little while ago, some of you might have heard him, some of you might not, that the answer is actually, even though the math says, hey, 4, the answer is actually no solution. This is a little crazy because math, up until this point, even if you didn't like it, even if you didn't understand it, it was like, no big deal. As long as I do legal, step A, step B, step C, I'm at my answer, D. If I do step 1, 2, and 3, I'm at my answer, and I have it right, and I can move on with my life, which is way different than other things like English essays. You do an intro paragraph, you do a couple body paragraphs, you do a conclusion. It might not be an A. It depends on the quality of your work, right? And the quality of your ideas and your analysis and all that sort of stuff. Or in history, if you're trying to answer like an essay question. If you do step 1, 2, and 3, it might not still be good enough to be like a work. But math is like do step 1, 2, and 3 legally. I'm at the right answer. How does this put all of that into question? Did we do the legal math of squaring both sides? Yeah. The problem was it was an impossible problem to begin with. How are you going to know? Well, A, if you do a lot of math, you go higher to where the stuff you're learning now becomes like basic, elementary, super foundational, and you just, by going higher and higher, you get a firmer and firmer grasp of the basics. For instance, I know the square root dude real well, because I've worked with him for a long time. And so I look at it and I'm like, oh, you silly square root, it can't be a -2, what's she thinking? No solution. My brain just goes there naturally. But you guys, you can't like cram into a couple months left of school. You can't cram in like years of working with the square root dude. That's not going to happen. So what's the way that you're going to find these extraneous guys? The super annoying word that lots of math problems always told you to do, and you were like, I don't need to check. As long as I do my work right, I'm fine. But what's the problem now?
You have to check.
You have to check because your right work might have landed you in an impossible answer. That's just, if you think about it, there's kind of like some ties in with life. A little bit. Like I did my best and I still didn't get there. Or I thought I had it and I was wrong. Even if I did the steps right, it doesn't always work out. Now, once again, if it's addition, if it's subtraction, if it's multiplication, if it's division, you're fine. Those are fundamental, always true, because the domains of those different types of functions, for lack of a better way of saying it right now, of quadratics and lines, you'll never have to worry as long as your steps are legal. But the square root guy is tricky, and the reason he's tricky is because he only works for certain x's and certain y's. And when I ignore him, when I bring in a squared and say, ha, you're gone, get out of here, I might get an answer that's impossible in the original problem, and that's why I have to check. So guys, can you see number 5? Can we skip down to number 5? We'll come back to 3 and 4, and I'll show you how we basically already did it up in the graph. But go down to number 5 real fast. Do you see, now careful. Do you see, if I were you, do you see the semicolon? Kind of hidden, some of you might not see it. Do you see the semicolon? Can you put in parentheses what comes after the semicolon? That x equals 1 and x equals 2, it's separate. It's separate from the problem. The problem is over here. The equation is over on the left. And then there's a semicolon, and then there's an x equals 1. I wish there was a little more space in there. So I'm sorry if that looks a little confusing. Put a little parentheses after the semicolon, just so that your brain knows, okay, here's the equation on the left, and here are the solutions on the right. Now they're asking which solution, if any, is extraneous. Which solution, if any, is extraneous? Can you guys write for yourselves off to the side, can you write the word check? They're just asking you to check. They've given you the answers already, and they just want you to check whether or not they both work. Which is really nice for you, because they're not saying solve. They're not saying do the entire problem. They're just saying check it. They're just saying check it. Let me get rid of this little blue guy. It's kind of in the way. So write down for yourselves. Are you writing it down, the word check? So check. How do we check, guys? What did I tell you to do over there? Check by what? Good. Do you need to write that down for yourselves? You can remember that? Check by. Okay, so put it down. Remember, when you get home and you're trying to do homework, and we might have time. I think we can do this in like 5 minutes if we do it carefully. Ready? You can still have your 10 minutes to work on homework. Write the word check, and if I were you, I would write down the word or the words by plugging in. So here we go. We have our square root of 3 times somebody minus 2 equals that same somebody. You put parentheses there so you know something is supposed to fill it in. What's the first somebody that we're going to check, that we're going to try? Yeah, so throw in 1. Okay, and now we got to do legal PEMDAS. Legal PEMDAS would tell me to do what first? Yeah, the inside. So what's 3 times 1? 3. Got to do multiplication on the inside first. After doing multiplication, now what?
1.
Yeah, subtraction. 3 minus 2 is 1. Is the square root of 1, you basically have a question mark, is the square root of 1, 1? Ah, well that was fine. So is x equals 1 extraneous? No, he's fine. Box him, he's a part of the answer. Yeah, he's good. We're going to box him if he's good, we're going to cross him off if he's bad. So ready, set, can you guys try? Can you check by plugging in 2? Can you try? Can you check by plugging in 2? Meanwhile, question. Armando, what's up? And as you guys are doing that, as you guys are plugging in, as you guys are checking, just a few of you might be curious enough to be like, okay, I get it. Sometimes they work and sometimes they don't. But you might be wondering, okay, I mean, that's great and all. They gave me the answers. Could I have found the answers on my own? Just a few of you would have thought of squaring both sides. Just a few of you wouldn't have thought of plugging in. You would have thought of, well, whatever, square both sides. My question is, if you're just kind of bored and chilling, you figured out whether or not 2 works, maybe come back and ponder and say, why is this so weird? In all of last night's homework, there was 1 answer. Why does this have 2? Did it work when you guys plugged in 2? Because 6 minus 2 is square root of 4, which is 2. So they both work? That's so different than last night, though, because last night only 1 answer came out of these. How on earth are there 2 answers all of a sudden? You don't have to do this. I'm not even sure if this is in homework, but what would happen if you guys did ignore their solutions and try to find them yourself? Wouldn't you have squared both sides? And doesn't the square root and the squared go away? So what's left over here on this side? But what's over here? X squared. Wasn't this like all of last chapter where we had quadratics and we were trying to solve for the 2 x's? What's different than last night's homework is that they're giving you trickier equations, and those trickier equations might end up with an x being squared, aka what we call a quadratic. And if you guys moved everything over to the other side by subtracting the 3x and adding the 2, maybe some of you would see, wait a minute, what multiplies to be 2 and adds to be negative 3? I think a negative 2 and a negative 1 does. And oh my goodness, a negative 2 and a negative 1, I believe that gets out for us a negative 2x, a negative 1x, and we have a 2. I can pull out a negative 2, I can pull out a negative 1, x and x. Does this make sense with the 2 answers that they gave you? Where did 1 and 2 come from? Do you remember how to get answers from these guys? We flip the sign of the intercept form, or we set each one equal to 0. If you go forwards, and if you went forwards very carefully, you would have gotten x equals 1 and x equals 2 by setting each factor equal to 0. There are 2 solutions. Now, hold on. Neither of those were extraneous. Both of those were just fine. But do you guys have another problem? Can you guys check out number 6? I was trying to show you, usually what you solve for is right. Usually what you solve for, even with radicals, is right. But every now and then, there's going to be a sneaky one that looks right and is actually wrong. As you guys plug in and check both of these, x equals 3 and x equals negative 2, I'm going to solve this guy off to the side. Check by plugging in. Figure out which one doesn't work. Oh, I just told you one is extraneous. Someone help Hannah out real quick. Which one doesn't work? We're grading both these worksheets tomorrow. Oh, nice job. The square root of 3 plus 6 is supposed to equal 3, and the square root of negative 2 plus 6 is supposed to equal negative 2. As you guys are testing and thinking and pondering as to whether or not that's true, I'm going to bring in and say, hey, wait a minute, maybe we could have done this ourselves and not had to use the book's answers. But if we had tried to do this ourselves, what would have happened? If we had solved it, we would have come up with the same thing that the book did. We would have come up with a 3 and the -2, and we would have thought that we were right. But the problem is, this radical guy says, I only take some x's. I only take some. As Jeremy already stated, have you guys figured out the same answer he did? The first one ends up working just fine. But the second one ends up failing, and the question is why? Yep. So what's something you guys need to take away from today and take into homework tonight? Can a positive square root, can a normal radical ever be a negative number? No. So anytime one of your solutions says, oh, a radical is a negative, you have to realize, that's impossible. This guy was just fine. That guy was extreme. The first guy was just fine. The second guy was extreme. Jonathan.
You do that different, but I'm still getting it the same. That's it.
Well, the directions that we wrote down, hold on, pause 1 second, was to check by plugging in. Okay? So technically, according to what I've said, you should be doing the exact same thing I'm doing by plugging in to the x each of these answers separately. That's all that I'm doing. So I'm just following the directions I gave you. But what are you doing where you're kind of figuring out whether it works or not?
Okay, I'm plugging it in.
Are you squaring both sides?
Yeah, I'm squaring this side.
Okay. Here's the struggle. If you square both sides, you're not going to realize that it didn't work, because if you square this guy, it's going to be 4, right? And if you square this guy, it's going to be 4. The problem is, if you ignore the radical, you're not going to know that it didn't work.
Oh, wait, no. Wouldn't that be -4?
Now, it's happening to work, but careful. Because when you square a negative, what's a negative times a negative? You're forgetting the parentheses. So it's a good idea. The problem is you're not putting the parentheses, and so actually you're kind of making some illegal math in there. And I just want you to be able to do something that always works. So what always works is always be on the lookout for whenever a radical is a negative number, equals a negative number, or has a negative number underneath. Be ready and be willing, be able to realize, oops, that was impossible. So as soon as I see a radical equal to a negative, I say no. Now you guys can see the homework up on the board on the side. I think we've gotten to the end of our examples. I'm going to go back and peek really quickly at number, what are the two that you kind of skipped, but we kind of did? Yeah. I'm going to go ahead and go back to those and show you how we really don't need to do them, I don't think, but I still want you to write a little piece of work just to help you in homework. But write down these problems first. Isaiah, you had a question, and then Caleb. Yeah. Caleb. So we have 23, 26 through 29, 45 through 48. I'm going to pull that up on the screen in just 1 second. But some of you guys had a big old awkward gap at 2 and 3. Nope, sorry, 3 and 4, right? So hold on, let me help you fill that gap, and let me show you why technically we already did those problems. I just didn't remember that you had a whole separate place to do them. Grab down the homework. 23, 26 through 29, 45 through 48. Get out a blank piece of paper or your homework spiral. I'm going to put that on the screen in just a second. You should get 10 minutes to work on homework, which is like yesterday. You should be able to bust out some, if not all, which is awesome, awesome, awesome. Okay, it's on the sideboard if you still need it. Let's go back to that awkward space in your work though. You guys have nothing for these two, but pause. Can you look up at the graphs right above these two? Doesn't number 3 come from number 1? Doesn't number 3 come from number 1? Doesn't number 4 come from number 2? So guys, I'm not going to make you solve this all over again, but what I do want you to do is that very first step. If we have square roots on either side, what was the very first step? If we have square roots on both sides, I do want you to write down square both sides. That way your brain, when you see it in homework, will remember what to do. And then you can write 2x minus 1 is equal to 5x minus 7. But can you guys also circle the word check? Because now we've realized with these radical guys, because we're not very familiar with the radical guys and when they work and when they don't, we need to check our answers in these ones. And sometimes they're illegal answers, even if the math looks great. They're called extraneous. Do the same thing on number 4. I'm not going to make you solve it. You can do a ... if you want, because most of you, if you were following along yesterday, did solve it with me already up in the graph. Square both sides. Show your brain and put down on your worksheet so you can see it when you try homework that those square roots are now gone. Oh, actually, it should be over the radical. And then you can write, hey, now I have 3x plus 3 is equal to x plus 1. And I am going to keep going. Just in case you didn't do this yesterday, if this isn't up in your graph, I will keep going. I don't mind. I will keep going. But I know some of you already had it done, which is why it's okay if you stop if you already had it done up above. For those of you that didn't have it done, maybe you were just listening and you weren't actually solving. Yesterday when we did these, 3x equals 6. That means x is equal to 2 when I divide both sides by 3. But we should go back and double check. We should go back and plug in now that we've learned that. Yesterday we had a graph, and so we didn't really need to double check because we could see it. Yesterday we had the graph, so we could see the answers, so we could double check with the graph, and it was technically okay. But now that we've learned today, if we didn't have a graph, sometimes it's illegal. We should go back and plug in each of these and make sure it works. But the nice thing is, they both do. I'm going to put little check marks because you technically have the graph to go look and say, oh yeah, they do intersect at 2 and at -1. We'll make that our double checking. And then in the rest of our work today, we've seen how to double check by plugging in. So, going to where your homework starts, which I believe is number, 23? Yeah. Number 23 and number 26, you guys get to do that whole, hey, use a graph thing, but then starting down to number 27, you're going to use our squaring both sides and checking thing that we did at the beginning of the worksheet. And then watching out for those extraneous guys like the end of our worksheet. Let me make this big so you guys can see it a little bit easier. There we go. And I think that's all of homework, yeah? Oh, okay, I don't have 45 through 48, but I don't think most of you are going to get any farther than these ones right here. So here we go. Homework, get done as much as you can. For those of you guys that started homework yesterday, we have like the best completion rate of homework of like the entire year today. Well, I guess 2 people. 3 people. But we had an awesome completion rate. But it's because you guys started. So start right now. Use your worksheet. You have your spiral, or you can use a blank piece of paper. Andrew. If you guys didn't write down the hint from yesterday, you might be stuck right now. The hint from yesterday on the graphs was find the x, if you need it, for all the graphs. The hint was find the x of the intersection. You don't really need to use that solving thing until you get down to the next section. This section, we're squaring both sides. This section, you get to actually just find the x of the intersection point. Because you can see it, and you can see that they intersect, and that's exactly what we want, the x of the intersection. So I'll give you a hint as you guys are trying to do the other ones. If you were supposed to do 24, your final answer would just be x equals, where is that? 5. And if you were doing 25, which you're not, but if you were, this guy would be x equals 2. We find the intersection and we find the x. We find the intersection and we find the x. So you guys do the exact same thing, but for those two. Yeah, Adrian. But you don't need to show work, but you do need to show your little graph. Just show a little like shoop shoop and be like, hey, look, it's where it's at. Melanie, do you have a question again? Can you mark on here as well? Armando, what you want is where it goes. And both the radicals go away. Armando, I know you have your phone. Why don't you go take a picture of this on your way out? Because this is what you didn't get written down on the worksheet, okay? There you go, bud. I don't know.